Hello, our today's topic is programming exercise in drilling. In drilling exercise, the workpiece is given as a square plate having 100 into 100 by 10 mm dimension, and on that we have to drill identical 4 holes of identical size of diameter 8, and the hole is placed uh, at 70 centimeter apart. The center to center distance between the holes in x-axis and in y-axis both are 70 mm, and the hole is of through hole, and it has to be drilled in a one single pass. So continuous drilling is employed in this experiment. The program is prepared in 3 steps. That is, first step is the main program. The main program consists of a canned cycle used in continuous drilling. Then, of course, in the third step, we are using the subprogram. So let's start with the main program. So the main program number is 1001. It is percentage 1001. Then G21 as usual, G21, G74, and G40 is given. Here the G40, that is the thing, that is G40 is used for cancel the cutter radius compensation, because the drilling means the center of the drill should exactly match with the center point where the drill has to be done. So there no offset is required, there is no cutter radius offset or compensation is required. Both has to be matched at the same location. So we need to cancel all the given cutter radius compensation, and for that we are using G40. Then G91 is used for make the tool on the home position. That is, the tool should be initially at the home position Z0, X0, and Y0. Then we are selecting the tool using M06 code, and the T2 is the tool code. That is, at the T2, the tool position 2 will be our required drill of diameter 8. Then D2 is the offset location or offset address of that particular tool. Then M03 is used to rotate the spindle in counterclockwise direction, and sorry, it is in clockwise direction. Then the cutting speed is 1500. Then first we will use the G00 code, that is for rapid traverse of the tool to a nearest position of the first location. So the first location is given as 15 by 15 in x-axis and y-axis, since our work 0 point is this one. The edge of the workpiece is defined as the work 0 point. So here it is our 0 point, 0 point. Okay, and the first using the C00, and by these again we are changing to absolute system. Then X15 and Y15 is this position, that is the position number 1, that is the position of the first hole, and Z it is 50, that means it will be 50 above the surface of the workpiece. If it is the surface of the workpiece, the tool will reach some 50 mm above that one. So this distance will be 50 mm. And after that we are calling the canned cycle for the drilling operation, continuous drilling operation, and the G98 is the known as return to initial position after performing this operation. Okay. Then G81 is the canned cycle for drilling, that is continuous drilling, and this EZ command is given with the depth of cut, and that is the drilling depth. That is minus 15 means it has to move. Our workpiece thickness is 10 mm only. So in order to have a through hole, we have, because we needed to pass the tip of the tool. The drill tip will be like this, so it will have some 180-degree for the tip angle is there. So some portion is there which is not having the full depth of the drill. So in order to have the full depth of the drill on the hole, we need to pass it some extra depth we have to give. So in order to get 10 mm depth, we are giving some 15 mm depth here like this. So Z minus 15 is actually representing that distance. Then another command is there, R47. Here the R is not representing the radius. So that is an important thing. You have to keep it in mind while doing this drilling experiment. So in candle cycle of drill, the R is used for some other purpose that will be explained in the next slide. Then the feed is given as 50 mm per minute. The R47, which is given in the candle cycle of drilling, is explained using this picture. So initially the tool is at a height 50 mm above the workpiece like this, and R47 means this distance is represented with this letter R. Then 47 means it is 47 mm. So that means if R47 is given, means up to this position, that is this is the initial position, this is the position number 1, and here it is the position number 2, and just touching the workpiece is the position number 3. The tool, whenever it is performing the candle cycle for drilling, the tool will first move from 1 to 2 in a rapid traverse speed, that is G00 speed, up to 0.2. So that we are defining up to what distance it has to move with the rapid traverse. And after reaching the tool 2, the position 2, the tool then it will move at a linear interpolation and with the feed rate specified F50. So from here onwards, the position 2 onwards, the tool will start to move and it will start to drill with the feed rate of 50. So that is the significance of R47. And after performing the drilling operation up to a depth of 15 mm from the surface of the workpiece, that is, this is actually representing minus 15, then we will get a through hole. After reaching the minus 15 point, then the tool will again go back to the initial position. This is the initial position, and that is the Z. Now here it is the Z is the 50. For getting to the initial position, we are using this G98. So after giving the candle cycle for drilling, next block is the subprogram, and in the subprogram we are writing the position of all the holes. So next slide we will discuss about the subprogram, and after executing this block we will finish all the 4 holes, and after finishing we needed to stop this candle cycle. So G8 is used for stopping the candle cycle, that is end of the candle cycle. Then G91 is again used for incremental movement of the tool. So again G28 is used, and Z followed by Z0 and X0 and Y0. That is again we have to make the tool to its home position. Then finally M05, that is the spindle stop, and M30 is the end of the program. In this third step, we are writing the subprogram. So the subprogram name is 3000. It has called at a single time in the program, because single time only the tool has to be moved from one position to another position. So we have to write all the positions of the holes here. So first position is already given from the main program itself. So it will perform the drilling operation over here, and after that we are calling this subprogram. So in the subprogram, the tool will be positioned to the second position, so that is x15 and y85, and third position only x has got the change. Now the x is given to x85, and that is this one, that's third hole. And finally we have to move to the fourth hole, and the fourth hole is at y15, and there is no change for x. It is retained at the x85 and y15. So that is the fourth position, the position of the fourth hole. And after performing all these things, again we have to return to the main program. So the total program will be right like this. So initially, at first it will the command will reach to the canned cycle. So the first hole will be drilled, and it will be then go to this subprogram. From the subprogram, it will actually, these two blocks will be executed hand in hand. So because we need to perform 4 holes, so 4 positions will be getting for position information from position information is getting from the subprogram, and using this position information, and the drilling information is provided in the canned cycle. So they are actually working hand in hand to drill all the 4 holes, and after finishing, the work will be stopped like this. If we needed to finish this workpiece in peg drilling mode, then uh, the G81 should be replaced with the G83, because G83 is representing the peg drilling cycle. All other steps are same. Thank you for watching.